Hi friends, today we are going to solve balanced bracket problem from the stack and queue subsection of the interview preparation kit. In this problem, our list of brackets should be given and you have to check whether those brackets are in a balanced way or not. So this is a very common stack problem where you have to use push and pop operations to check whether those brackets exist there or not. So to do this, first we will have to create a dictionary. So let us first initialize our stack. Let's so you know that in Python we don't have anything called stack, but we have list. So we will try to replicate a stack in a list. So here in this stack we'll be initializing with the string value of 0, the list of the stack, and we will create a dictionary dictates and its value. So whenever you get a opening bracket, so it when key of a opening bracket is the value of or the when the key is opening bracket is value is closing bracket. So it's something like this, although I cannot exactly say it. Kind of confusing, but I hope you understand the entire process. So this would be done. I will tell you why these are required. So in our code, whenever we get a value of closing bracket, so we'll be checking whether let's move on to the example. I think it will be much more easier to explain you. For I in range, I keep on making a mistake. For I in range from instead of 0 to the length of the string, here we are at starting from 1 to the length of the string, because for the 0th index we have already added that value to the stack. So length of s. So if so the idea is, let's take an example of this value. This is our s. Current value of s is this, and the current value of our stack, as we have already initialized with the value of the first character, so the current value of our stack is going to be this one. So the next value, which is going to be this bracket, so you would be checking whether this value is equal to this value. In this case it is not going to be, so we will be just adding that value to our current stack. And to get the last value of this stack, we would be using -1. So if the current value of this stack is equal to s dot I, so we'd be using stack dot pop, else stack dot append. We keep on forgetting this is a list, so there is no push function, but there may be, I don't not sure about it, but according to me it's better to use append. So for the first condition it's okay. Now the second condition. So now our stack value is this bracket, which corresponding to the last element of the stack, and our new element of the s is this, so which is not equal to this one, so we'll be again appending that value to our stack. Now for the third element, is this value equal to this value? In reality it's not going to be, so we can push this value to the queue, but we need to understand that what we are trying to do, we need to check the key. This is the key, and we need to check the value corresponding to this key. So here we would not be checking this exact value, but we will be checking the corresponding value associated with this key. So this value would be considered to be a key. So we could check that dictates. So we have already specified our dictionary. So reason for doing this dictionary was this. So dictates where the key is, so dictates key, so the key corresponding to this. So if we do this dictates, then automatically the value we'll be getting out of it is this. So this could automatically be written as, so in this case these values are equal, so we'll be popping and this element out of the list. So here we need to modify our stack to dictates, so that we find the key value pair of it associated with it, and similarly for the next value of this bracket, so dictates of the latest element is this, so dictates of this is equal to this one. So we could automatically check this is the key and this is going to be the value. So these and this is going to be equal, so we'll be popping that element out of the list. And similarly for the last element, we would be checking whether the opening bracket is equal to the closing bracket, and to do this we will again refer to the dictionary. So opening value, if is the key, then value is going to be the closing bracket. So this and this are equal, so you will be popping that element out of this list, and the current length of the stack is going to be 0 if it's balanced. So if length of stack equal to 0, return yes, else return no. So this is the basic idea, but till now it's not entirely solved. So I will tell you what's the issue that's going to happen. Let's run the code. As you could see, it is saying that there is a key value error. So it is not able to find this key. So in such a scenario, for example, there could be a situation right now we have able to, this is perfectly balanced, but there could be a situation where we could get some values like this. So in that case, it won't be able to find that value in the dictionary. So you have to write a condition to safeguard it. So in that case, we would be doing so in this condition, we are checking whether that value is a key in this dictionary. So there could be a situation where a closing bracket is never going to be a key, of a dictionary. So in that case, we'd be basically appending that value to our list. So this is the condition that you need to check. So let's run the code. As you could see, there is also a condition which says that this list is out of range. So what is happening out here is that, let's take this example again. So we have tried to solve this issue, but I think if we submit this code, there will be a few more errors, and this error is very simple to understand. Although it's passing a few test cases, but majority of the cases are failing, which is not a good sign. So now this list has been perfectly balanced, but after this operation, after all the operation is completed, this stack is going to be empty. So in that case, what is going to happen? So in that case, if you're going to find the -1th element in this stack, then that value would not exist and it will throw an error. So we have to make a condition that if the current value of this stack is empty, or if there are no value in this stack, then the next value is automatically going to be get appended to that stack. So to do this, we'll be checking if length of stack not equal to 0, and so in this condition we are making sure that the stack value should not be empty before we are going to pop an element, because if the stack value is empty, then it will throw an key value error, or I think the error we got, or out of range error. So those type of error, to reduce those type of scope, we need to do this. So now let's run the code, and I think it will give us a correct answer. Let's submit it. So we have been able to successfully run this code. Now, if we want to even simplify this code, then because we have already checking the length of it, so no need to initialize stack. So stack can be empty. And in that case, we'll be looping through from range of from the 0th element to the length of the string. So in this case also, it would work most probably. Let's check. As you could see, it passed the test cases successfully. Let's check for the private test cases. And as you could see, it passed all the private and public test cases successfully. So this is the video, guys. So if you have a better way of solving this solution, feel free to comment below. So right now, I think it would be it would be around big O of n, but to search the element in the keys would take some time. So it would be a little bit more than big O of n. So this is the complexity of the problem. So if you find a better way of solving this problem, then feel free to comment below and also share your knowledge to the community. That would be really, really helpful. And as always, thanks for watching and stay tuned.